This video deals with the following topic: solving linear quadratic systems of equations. What does that mean? Okay, what it means is that you're going to solve a quadratic equation and a linear equation simultaneously. Now, when we solved, or in previous videos where simultaneous equations were dealt with, both equations were linear. Now we just have a case where one equation is a quadratic equation and the other equation is linear. And in order to solve such systems of equations, all you have to do is plot the two equations on the same piece of graph paper. The solutions are given by the coordinates of the points of intersection. Now, what are solutions? Well, we have an equation here and we have another equation here. And you're looking for the unknown variables x and y. You're looking for an x value and a y value, which is such that satisfies equation 2 and equation 1. So you're looking for x. So you're looking for a pair of x and y values, or a pair of x and y values that satisfies the quadratic equation and the linear equation. And the thing about this is that you can have two pairs solutions. So you can have, say, x is 1 and y is 2, and you can have x is 3 and y is 7 or something. And this solution will satisfy the equation, and this solution also satisfies the equation. But that's not necessarily the case for this system. We need to solve it, and in order to solve it, like I said, you simply plot the two equations on graph paper. So I'm just going to use a sketch. So I'm going to plot equation 1. It's a quadratic equation, so I'm just going to sketch what the plot's going to look like. You can try plotting it on graph paper. Now, the sketch of the quadratic equation is going to be a parabolic curve, and it's going to look something like this. So what you have to do is generate a table of values and actually plot the curve. If you do so, you get something that looks like this. And the next thing I'm going to do is plot this straight line, y equals 2x plus 6. When I generate a table of values for this equation and I plot, I will get a straight line like this. Now, when you do such a plot, make sure that the plots of your two graphs are such that you can see all the intersections of the two graphs. Here we can see that the straight line intersects the red curve at 2 points. So I'm going to use green. Now I'm telling you that the solution to the system equation is just the coordinates of the point of intersection. So if I call this point point A and call this point point B, the coordinates of point A are given by, in this case, -3, 0, and the coordinates of point B is given by 2, 10. So when you actually plot this accurately, this is what you'll get. And that's all. That means your solutions are x equals -3 and y equals 0 based on the coordinates of this point, the x coordinate and the y coordinate. And the second solution is given by x equals 2 and y equals 10. And it works. We're going to test these values. Okay, let's test solution 1. I'll do that here. Solution 1 says x is -3 and y is 0. So let's test it in equation 1. Equation 1 says y is equal to 2x squared plus 4x minus 6. So I'm going to replace x with -3. Now, if x is in fact, if this solution x equals -3 and y equals 0 does satisfy this equation, when I replace x with -3 in equation 1, the y value I get should be 0. So let's try that. Replacing x with -3 in equation 1 gives 2 times -3 squared plus 4 times -3 minus 6. All I've done is replace x with -3 in equation 1. Simplifying gives 2 times 9, which is 18, plus 4 times -3, that gives -12 minus 6. 18 minus 12 is 6. 6 minus 6 is 0. As you can see, when x is -3, y is in fact 0. So this solution is valid. Well, it's valid for equation 1. Let's test it on equation 2. Now, when x is -3, I have on the right hand side 2 times -3 plus 6, which is y equals -6 plus 6, which is y equals 0. Again, this solution satisfies the equation. So this solution satisfies both equations. So this solution is valid. So anytime you solve a linear quadratic system, after plotting your graphs and reading off the coordinates, test your solutions, because it lets you know that your answer is correct. So in an exam, you can go home and know that I definitely got that question right. So now you try this at home. Try testing the second solution. So what you do is replace x with 2 in the first equation, see what y value you get. If that y value is 10, then that means this solution is correct. Do the same for equation 2. Replace x with 2. If you get a y value of 10, that means this solution is correct. And you find that it is. So this graphical approach does work. So let's try another example. Here we have another quadratic linear system of equations. Here's the quadratic equation in the system, and here's the linear equation. Now in order to solve this system of equations for x and y values, corresponding x and y values that satisfy the two equations, we need to plot the two equations and read off the coordinates of the points of intersection, and we're done. So I'm going to give you a sketch. You can try plotting this at home accurately. I'm going to give you a sketch. So I'm going to first plot the quadratic curve. So this is just a rough sketch. So this is the positive y-axis, positive x-axis. Let's make this neater. Negative x-axis, negative y-axis. So here's a plot of the quadratic curve. It's going to look something like this. When you plot it, this is what you're going to get. And a straight line is going to look like this. The point of intersection, here's 1. I'm going to call this point A. And here's 2. I'm going to call this point B. All you have to do is read off the coordinates. And when you read off the coordinates of point A, you find out point A has coordinates. Let's write that here. A has coordinates 2, 6. And you find that point B has coordinates 4, 6. Therefore, the solutions, or the first solution is x is equal to 2 and y is 6. Second solution is x is equal to 4 and y is equal to 6. Let's test this solution. Let's test solution 1. So here we go. When let's replace x with 2 in both equations. In equation 1, replacing x with 2 gives y equals 3 times 2 squared minus 18 times 2 plus 30. This gives y equals 3 times 4, 12, minus 36 plus 30. This simplifies to give 12 minus 6, which is 6. So it gives me y equals 6. When x is 2, I get y 6, which is what the solution says. Let's try the same result in the second equation. When x is 2, in the equation 2, y is 6. As you can see, this equation just says y is 6. Regardless of what the x value is, this equation just says y is 6. So this is a valid solution. Let's test the other solution. X equals 4 and y equals 6. So I'm going to replace x with 4 in equation 1. Let's use a different color. When I do that, I get y equals 3 times 4 squared minus 18 times 4 plus 30, which gives y equals 3 times 16 minus 18 times 4 plus 30. This gives y is equal to 48 minus 18 times 4, 72 plus 30, which gives y is equal to 6 when you simplify. So we replace x with 4 and we get a y value of 6, which is what the solution says. In equation 2, regardless of what the x value is, y is 6. So this is also valid. So here are the solutions. So to just neatly write them out, first solution, x equals 2 and y equals 6. Second solution, x equals 4 and y equals 6. So these are the solutions to this system of equations.